Next, I'd like to do an example where we walk through this slightly improved algorithm that we have on the Big of Words model, just showing you a little bit how it works. I've got 3 example sentences up on the screen, and I've got a chart that has a handful of positive and negative words in it over here on the left. And X1 reads, "I returned the item, not what I expected, very disappointed." So fairly straightforward negative review. Sentence X2 says, "Nice, clear images, but very slow and the ads are annoying." So it seems like maybe it's a negative review, but it's not quite as strongly worded as the first one. And the third review is, "This tablet has been the best one for the price. We have purchased 3 other tablets for our kids and they all ran super slow. They love them." So clearly a positive review, but you can see we have a little bit of an issue as they start to reference other tablets and attribute those negative aspects to the other tablets, but we don't necessarily have a way of picking that up in our model. So we go through our score calculation using the chart on the left. That first review, X1, had a returned and a disappointed in it. So we look up the weights for returned, we look up the weight for disappointed. We take the sum of those 2 weights since we only had 1 occurrence of each of those words in our sentence, and we get this very negative score. For that second review, which was a little bit more neutral but seemed to still be on the negative side of things, we had a nice, we had an annoying, and we had a slow. And so we have a 1.2 counting in our favor for a nice occurrence, but because we have that annoying and slow occurring in the statement of the sentence, we have to subtract a 0.9 and subtract a 0.7 coming from this chart over here. So altogether we get a negative value predicting that the review is a poor review, but it's not quite as large as this negative 7.0 we saw over here. And on that last review, which we read and thought was a positive review, we had occurrences of the words best and slow and love. So we look up those 2 positively connotated words, best and love. We look up their weights in the chart, and then we take into account that there was that reference for something being slow in the review. So we subtract a 0.7 in the end, and we get a positive number, 5.8. So altogether, it seems as though we've given the most extreme sentiment to the first review in the negative direction, and then we have this more neutral review having a value somewhat close to 0. Now, we had those 3 example sentences. It wasn't too bad to read the reviews and take our own emotional gauge on how we thought those reviews were associated, either positive or negative, but in essence, we'll be looking at really large data sets. We don't want to have to do that all the time. And so we got this negative 7.0, but that was a pretty short review. There's 30,000 reviews out there. Some of them might go on and on and on. And so although negative 7 is a much bigger number in absolute value than negative 0.4, we can realize that one of those reviews is worse than the other review, but we don't know just how bad that review is without looking at the entire corpus of reviews that we have, and we don't want to have to do that. In theory, we could have these scores ranging all the way from negative infinity to infinity, and we aren't able to gauge how extreme a particular review is relative to all the others without looking at a lot of data. We don't want that. We want things to go quickly. So what we're going to need to be doing is looking at what's called a link function that's going to take our values in this range of negative infinity to infinity, and it's going to normalize them by putting them into the interval 0 to 1. And then what we'll be doing is thinking about the number that is output by this link function as a probability. And what it's giving us is the probability that the review is a good review. So we would want something that has a very high positive score. There's a very high probability that that's a good review. And high probabilities are things that are close to 1. Almost a 100% chance that that is a good thing. If we have a review that has great, amazing, fantastic, fabulous written all over the place, that's definitely a good review. On the other hand, we want to go the other direction in terms of reviews with a very negative score. Terrible, returned, disappointed, all of those things that come up over and over and over again, no very positive words, we want that to go very close to 0. There is almost no chance that that is a positive review. And scores more like that x2 sentence that had a negative 0.4, which was pretty close to 0. In many ways, it's almost like a coin flip, right? I don't know, maybe it's good, maybe it's bad. There's sort of a balance of good words and bad words, and I don't know at this stage if that's a positive review or a negative review, so we want the output of that to be close to 0.5. So the link function we're going to focus on today, which I'll talk more about in the next video, is called a sigmoid function, but it looks like this. So I've only graphed it from -5 to 5 on this interval here, but I've shown the score along the x-axis and the probability that's output by that sigmoid function on the y-axis here. I've drawn in a half for you. So you could see right here with a score of 0, we're going to have an output of 1/2, ticking off this last criteria that we have. As we get these very, very negative scores, you can see the probability approaching a 0. And as we get these very high values over here, you can see our probability approaching about 1 here. So this sigmoid function that we're going to learn more about next does all of the things that we want it to do, translating scores into a normalized range.